our YouTube channel of series of basic process engineering calculations. In this session, we will focus on how to calculate the NPSH available required. As you all know, to size or to design any centrifugal pump, you need to give the data to the manufacturer, like what is the NPSH available for that particular pumps. So based on that, they check for the NPSH requirements and design the pump accordingly. So we will learn about how to calculate the NPSH available for the different scenario, like suction lift, then static positive head, then under vacuum. Okay, so first we will understand what is NPSH available. Okay, so NPSH available is the static head or static pressure required at the pump suction, or it is a pressure above the vapor pressure of liquid at the pump suction, and that helps to avoid the cavitation. Now we will just brief you about the what is cavitation. Cavitation is the process of formation of vapor bubbles at the impeller eye or the casing of the impeller or pump, and then that formed bubble or air bubble collapsed, and that release the energy, and that can damage the impellers or pumps metallic parts. So I just explain you how the cavitation occurs with the simple help of with the simple snap. When liquid enters, it contains some air bubbles or like vapor formation, or that's called technically cavitation or cavity that enters through the impeller eye, and then as the pressure increases, the bubble formation goes on higher side, and that collapse after certain distance travel through the impeller, and that can damage the pump casing as well as impeller. Okay, so now I just explain you how to calculate the NPSH available for the different cases using Excel. As you all know, you have suppose you have to calculate the NPSH available for the any particular reactor which is at the first floor or any tank, and below that tank we have a centrifugal pump for the transfer of that material. So we have to give the what is the actual NPSH available in the process data sheet or URS to size the pump. So here I have considered the first case is that we have static suction head. Okay, so this is the first case. In that case, we have open tank at the elevation of 4 meters from pump suction line, and that is open to atmospheric pressure. So first I will show you how to calculate NPSH. What is NPSH? NPSH available is equal to P absolute pressure above the liquid level, then the static head at the pump suction, and we have to minus the pressure drop across the piping and fittings like elbows, strainer or walls at the pump suction. And lastly, vapor pressure of liquid. So that gives the value of what is actually NPSH available at that pump suction. Okay, so in this case we have, with using this above stated simple formula, we just try to calculate the NPSH available. First we have, this is a open to atmospheric tank, then that means we have absolute pressure P absolute is equal to 10.33 meter. Then what is the static head or static level from the pump suction center line to the liquid height, that is 4 meter. Then we have to minus the vapor pressure of liquid, and in this case we just assume the vapor pressure. Okay, just vapor pressure of liquid at 32 degrees Celsius. Okay, you can consider it as a water, that is the vapor pressure. Then this, we just note down each static head at pump suction, so you will get idea. 4 meters as shown here, static head. Okay, then we have to calculate the delta P at pump suction piping. Okay, so I have already explained you how to calculate the pressure drop across the piping, so you can calculate based on that how much the length of that piping, and using the simple Darcy-Weber's equation you can calculate the pressure drop across the pump suction piping. Okay, so here for reference purpose I have just already taken calculated values here. Okay, then we have to calculate take P absolute at liquid level. Okay, so P absolute, as this is atmospheric, then hence I consider the P absolute 10.33 meter. So using all these uh, available data, we can calculate NPSH available with simply putting that values. Okay, minus vapor pressure minus delta P due to fittings. For this particular example, our calculated NPSH available is 12.65 meter. Okay, that means key uh, you have NPSH required margin, because NPSH required should be less than the NPSH available. There should be a difference of at least 3 meter as per the thumb rule. Okay, so hope you got the idea about how to calculate the NPSH available for the such example where static head is available. Now I'll explain how to calculate, as you may got a doubt or you think okay, that's okay for the static head available equipments or pumps. How to calculate the NPSH for the application where we need to lift, suction lift from, like pump is located above the liquid level, or we have to pump the liquid from the underground tanks. So I will explain that into another case, case 2. Okay, so in case 2 I already have taken one example here, snapshot here, so you can get the idea. Okay, this is the tank which is below the pump suction line. Okay, so to calculate NPSH available in such cases, I will explain P absolute as it is in atmospheric condition. P absolute remains same. Instead of static head, we have to minus the suction lift here because we need additional energy to lift that liquid. Okay, hence we have to minus that. So stat suction lift, I'll just update here, suction lift at pump suction. Okay, so rest of the things or fundamentals concept is same. So suction lift is 2.5 meter, then vapor pressure of water we can keep at as it is 0.18 at 32 degrees Celsius. Then delta P across the suction piping, as I have taken an example with all the values so that we don't waste time to calculate the delta P across the piping using the pipe length and fluid properties. You can calculate with the reference of delta P Darcy-Weber's equation, and you can get all the values here. Okay, so here we have to just minus the suction lift, hence our NPSH available is 5.65 meter. Okay, hope you got the clarity about the NPSH available calculation for the static head available conditions and the suction lift available conditions. Okay, as I just want to explain you that why this is important to avoid the cavitation, because the cavitation happens due to the NPSH available on lower side that could damage the casing and pump mechanical seal, that could create the abnormal sound noise, and it affects the pump performance as well as the efficiency. Okay, so hence this is the most important concept or parameters while need to consider while the sizing or designing the centrifugal pumps. Okay, and in next session we will explain you how to calculate the NPSH available for the cases where the vacuum under vacuum conditions and other. For now you can practice it with your process parameters or at the equipment conditions at the plants, and you can practice it so that you will get the clarity about how to calculate and what is the actual NPSH. And it's simple as I explained in simple 3-4 lines. So I hope you got the clarity. Still you have any queries, you can drop me a message in a comment section so that I can revert you or clarify your doubts. And if you like our videos, please subscribe our channel, and thank you for now. Bye bye.